should be starting up. Should be. Let's turn this way down. This is Christmas music. Let's just do regular music. Here we go. That's fine. Yeah, okay. All right, so we are jumping right in. We are working on, holy moly, that's loud. We are working on Java and object-oriented programming. So we're gonna start with object-oriented programming first, and just kind of, my goal is to do some memorization for important topics, features of object-oriented programming. I know that there's 4. This is going to serve as a study session for me and answering questions for anybody that has questions on Java or object-oriented programming. Java itself, I am recently learning Java. So today we're going to do some coding in Java. So we're going to do some like LeetCode problems and some hacker rank. There's one more program I forgot, or application, web app that we'll be using as well. Okay, so object-oriented programming. This is our topic for the day. I know from off the top of my head there are 4 important features. Encapsulation. I'm going to spell a bunch of stuff wrong here. Inheritance, polymorphism, and abstraction. Okay, so right off the bat, I'm going to just say that this is like keeping variables private and using getter, setter functions. And I'll go into detail about what this is. Inheritance, subclasses, sub and super classes. Polymorphism, there are 2 types, runtime and static polymorphism. Is that right? Static? I don't know if this is right. Let's just explain a little bit about this. This is, you can have the methods of the same name. Methods of the same name. Let's just say that. We can also say methods / functions of the same name will behave differently based on context. This is also overriding. I don't know if I'm spelling this right. Overriding versus overloading. Oh, sorry. Overloading. Okay. And then abstraction, this is the difference between abstract class and template. An interface? Interface. An abstract class and an interface. Okay. Here we go. So lots of stuff to define. In object-oriented program, these are some important. The reason I bring these up in particular is because I was asked these questions in an interview. So I want to make sure that like I have these down like pat. Like there's no way I will ever get them confused. Let's start with encapsulation. So we'll take this and we'll make it a title, a header. What the hell is that? Okay, encapsulation. Come down here. All right, encapsulation. Let's go ahead and jump on the internet and use some definition. Object-oriented programming encapsulation. So, encapsulation is a fundamental concept in object-oriented programming. It's commonly used to develop complex software systems. Encapsulation is most commonly associated with object-oriented programming, where it is a fundamental principle. Still, that's like not super helpful. Yeah, we need some actual like definitions. It says declare data members as private. This restricts data access to the data from the outside. Provide public methods, getters and setters. And then implement data validation, where the setter method. I guess, yeah. So these are the three things, I guess. There's some benefits. Data hiding and integrity. Right. Okay, so I've already kind of explained that, but this just goes into more detail about it. So let's go ahead and just put this here. Provide public methods, getters and setters. These methods act as intermediaries, allowing control, access to the data. Getters retrieve data, and setters modify them. Implement data validation. Within the setter methods, you can validate data before assigning it to the object's properties, ensuring data integrity. Okie dokie. Okay, so I got that. Next, let's just do a double take on object-oriented programming important features. Let's just see what this says really quick. Class, objects, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and message passing. I have never heard of that. So let's read this too. So classes are used to define data type. Easy. A basic unit object-oriented programming is the object, represents real-life entities. Yep. Identity is the name of the dog. State. This is the class. The class. Oh, this is the object itself with its. What is it? With its characteristics. Data abstraction. That's next. So data abstraction. Data abstraction is one of the most essential important features of object-oriented programming. Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details of implementation. Consider a real-life example of a man driving a car. The man only knows that pressing the accelerator will increase the speed of the car, or applying brakes will stop the car, but he does not know how on pressing. So this is abstraction is you get kind of two. Well, in Java you get two things: abstract classes and interfaces that kind of give you an example, like a better understanding of like leaving the implementation and stuff up to the user, not the user but the programmer. Encapsulation, inheritance. So single inheritance, multiple inheritance, multi-level inheritance, and then hierarchical inheritance, and hybrid classes. What does that mean? That's kind of weird. I'm gonna just take this and put this under inheritance. Right. We'll take this, copy it here. Inheritance, polymorphism, abstraction. Oh, this stream is only gonna be an hour long today because I gotta go do some other stuff. Abstraction. Okay, so under inheritance, I'll copy this. Put this in here. Just make it smaller. Let's go and center this. Oops. There you go. There. Okay. Let's kind of give a brief description of inheritance. The capability of a class to derive properties and characteristics from another class. Okay, that's fine with me. The capability of a class to derive properties and characteristics of another class. Did I write something about sub and superclasses? Also, so like sub and super classes are just parent and child relationships. Okay. Let's look at let's validate that. Sub and super classes in Java. Understanding superclasses and subclasses. Superclasses and subclasses form the backbone of inheritance, a core concept that allows new classes to create based on existing ones. That's it. Sub and superclasses are just parent and child relationships. Right. So back here. Right. So data extraction, classes, data abstraction. God. Encapsulation, inheritance, polymorphism. So here we go. There is runtime and compile time. So that is runtime and static, but this is actually compile time. So runtime and compile time, function overloading, operator overloading, and then virtual function. Function overloading, I know what that is. Operator overloading? That doesn't ring a bell. Okay. Let's get back in here. So let's copy this image. Put it in here. Make it smaller. Make it in the middle. The word polymorphism means having many forms. It's fine. So I don't know. Okay, so I know that there is under compile time, compile time. We have the two types. So we'll put a dot there. We'll put a dot here. It's function overloading and operator overloading. Oh, I think I know what this is. So it's like function overloading is whenever you have like in a single class a function that can take many different parameters. So it's like, let's say like we have a function that let's say we have add, and you can add two numbers together, or you can like if you put in two numbers it'll just add them together. But then let's say we have the exact same function called add, and it will take like, you can put an array into it. So you end up with two functions. You have one that has two integers, and then you have the same function named, but instead it takes an array. That's a function overloaded. Now operator overloading, I think what it is like whenever you you can like define how to complete an operation based on its class. So if you like wanted to do add again, but your like class has lots of variables and stuff, you can define how add works for the classes. So like when you add the two classes to each other, it'll do it based on the definition that you've supplied. Now runtime. Let's go ahead and put this. That's not what I want. Runtime. Virtual functions. Virtual function. This is like, I think it's like whenever you have inherited a class and that you want to overwrite what the function it does. So for example, if you have bird as a parent class, and then you have duck as the child class, in the parent class you'll have defined something like speak. So like a duck, oh no, sorry. you have bird as the parent class, and the bird speak will be like tweet, tweet, tweet. And then inside of a child class that inherits from bird, let's say duck, its speak function will have it'll overwrite the parent function, and it'll say like quack. And that's the difference between overriding and overloading. Visual function. This is overriding. Overriding. And this is overloading. So child class defines function that exists within the parent class. Okay? Class contains multiple functions of the same name, but that will take different parameters and complete different actions. Let's just say that. And then this is defining how a class will. I'll look this up. This one I'm not sure of. Defining how a class will handle operators such as equals, add, or addition, subtraction, etc. Okay, operator overloading. Okay, let's look this up. Object-oriented programming. Operator overloading. Operator overloading. Okay. So class complex, operator plus complex constant, blah, blah, blah. Okay, so operator overloading is a compile time polymorphism. It is ideal for giving special meaning to an existing operator. Yeah, so defining how a class will handle operators such as equals, addition, subtraction, etc. This is also considered redefining the, I spelled redefining wrong. Yeah, redefining the existing operators function on the class. Because it needs to be defined inside of a class. You can't just redefine it in the main. I mean, I guess you could, but oh, excuse me, sorry. Okay, got it. So that's polymorphism. It's inheritance, encapsulation. Last is abstraction. All right, let's get that. So dynamic binding. This is a little bit more. I have no idea how this works. Dynamic binding. The code to be executed in response to a function call is decided at runtime. Dynamic binding means that code associated with a given procedure call is not known until the time of the call at runtime. Until the time of the call at runtime. Dynamic method binding. One of the main advantages of inheritance is that some derived D class, or class D, has all the members of its base class B. Hence, D is not hiding any of the public members from B, then an object of D can represent B in any context where B should be used. This is known as subtype polymorphism. Let's go ahead and write this in here. Subtype polymorphism and dynamic binding. Okay. The ability to... Oh, okay, hang on. Actually, let's use GPT to simplify this. So we're going to take this. We're going to go to GPT. Chat Can you please simplify this explanation? Dynamic binding is when code that runs in response to a function call is determined during program execution rather than before it runs. This allows objects from derived classes to be used where their base class is expected, as long as they don't hide any public members of the base class. This feature is called subtype polymorphism. Can you give me an example? Can you give me an example? Sure. So class animal sound. Dog extends animal, it makes a new sound. So animal makes a sound, dog barks, cat meows. Public static main string arguments my animal equals new dog my animal. This doesn't seem any different. My animal is a reference. The dogs are barking. My animal is a reference of type. The dog's barking. Sorry guys. It's assigned to dog object, then cat. Sorry. When my animal sound is called, Java decides at runtime which sound method is to be called based on the actual type, dog or cat. That dog is barking. Sorry. How do I... Hang on, let me see if I can... Maybe that'll help. I mean, not really. Hang on. Let me see if I can change my microphone. Here's things. There we go. That should help. With some... Add some extra... it's a directional microphone, so I can make it like stop listening behind it. That should help with the sound. I had it like looking around before. Alright, let me just turn this on. Turn that down. Okay. Back at it again. This doesn't really seem like subtype. Let's look up. Let's jump out of here. Let's look up subtype polymorphism. Conceptual difference between parametric and subtype polymorphism. Subtyping: bird, duck, cuckoo, ostrich. The notion of subtyping is program language. Conceptual difference between parametric polymorphism and subtype polymorphism. I've tried to read through Wikipedia, but it's so dense on the subject of polymorphism. My understanding of subtype polymorphism is related to subtyping, and parametric is related to methods being generalized across different classes. What am I missing? Parametric polymorphism allows a function or a data type to be written generically so that it can handle values identically without depending on their type. Allows a function or data type to be written generically so that it can handle values identical without depending on their type. Parametric polymorphism is also available in several object-oriented languages where it often goes under the name generics. For example, Java or templates. Templates, okay. So what this means, as an example, if you can make a function that takes a list of somethings and the function can work no matter what those somethings are, think of a method that returns the number of elements in a collection. You can pass in a list of any type of elements and it will return an answer. You don't have to write the functions for every kind of list you pass. Okay, that's template. Subtype. Let's just write this here. Templates. Template functions / template data type. I've used this before. Some languages employ the idea of subtyping to restrict the range of types that can be used in particular case of polymorphism. In these languages, subtype polymorphism, sometimes referred to as inclusion polymorphism or dynamic polymorphism, allows a function to be written to take an object of certain type T, but also works correctly if passed an object that belongs to type S that is a subtype of T. Oh, got it. Okay, so let's go ahead and erase this. Or not erase it right away. We're going to do parametric polymorphism versus subtype polymorphism. So the parametric is the template function and template data class, or data type. Subtype is functions or methods can handle a subclass and hang on, what comes first? Allows a function to be written to take an object of a certain type T, but also works correctly if passed to an object that belongs to T S, that is a subtype. Can handle a particular class T and also a class S who is a subclass of T. Okay, awesome. Templates. In other words, you can have a method that takes an animal as a parameter, but you can also pass in cat or dog into it because cats and dogs are animals. I will take this. I'm gonna copy this. Copy this. Paste that. That's a good explanation for that. And then this one, I'm gonna take this as well. Very good explanation. Copy this and put it in here as well. Okay. Okay. All right. That's information. Good information. I don't want to read that. Seems like too much. Let's go into here. Data abstraction. Data abstraction. Okay, so data abstraction is abstract class and the interface. Abstraction in Java. Let's see what it gives us. Abstract classes and interfaces, anything else? I mean, it gave me exactly what I thought. Okay, so it was about 30 minutes of theory. Let's get on to some coding. Oh my gosh, my back. Oh, my back hurts. Okay, let's get into some coding. I'll finish this up later. I will go ahead and just copy this just really quick. Just get it in here. Okay. Drop to my desktop. I'm going to program, column notes. Close this. Okay. Let's go ahead and drop some of this stuff. All right. We have 3 programs to use here. We're going to do LeetCode. We're going to do HackerRank. Am I logged in? Sign in. On. All right. Oh, wait. Can I go back? Fuck. For job interviews. Hey. Hey, what the hell? Settings. Oh my gosh. This is exposing me. Good Lord. All right. So, what is this? Challenges 54. Problem solving basic, problem solving intermediate. This interview preparation kit has challenges curated by our experts for you to prepare. I've never used this. I use LeetCode like on the regular. Done all the easy problems. Create a job winning resume. Oh, okay. Let's do it. Plus, minus, success rate, skill, problem, basic. Let's see. Am I okay? So I need to be writing in Java right now. What version of Java should I use? Java version is dependent on your specific case need. Which Java version? By learning a newer version of Java is not like you're not going to learn the basics of the previous version, but it's true that there are some big improvements like streams. Damn it, man. Alright, fuck it. It doesn't really matter. 11 is fine. No, this is C++. Let's go Java 15. Is that fine? Alright, there's nothing else. Java 15. Holy crap, you've imported a lot of stuff. Okay, give an array of integers, calculate the ratio of its elements that are positive, negative, and 0. Print the decimal value of each fraction on the new line with 6 places after the decimal. Positive, positive, 0, negative 1, negative 1. There are in elements 2 positive, 2 negative. Their ratios are 2, 5, 2, 5, and 1, 5. Okay, that shouldn't be too hard. Plus, minus, solution. What is this? This better... Wait. Okay, complete the plus minus function below. The function accepts integer array as parameter. Write your code here. Okay. So I will just write a... so this is... I haven't been writing Java for very long, but I know what I want, and it's going to be 3 integers. Integer... positive. Do I need semicolons? It looks like it's throwing me an error. What's wrong with you? The value local positive is not used. Ah, okay, fine. So we'll just set this to 0. Int negative equals 0. And int 0 equals 0. We'll call this zeros actually. Now, integer list array. So I want to go through an integer. So I'll try to do a for loop. For int I equals 0 so long as I is less than r dot size. Is it a function? Looks like it. Yep. I plus plus. So I'm gonna loop through. And then if r I equals 0, then set a, it's gonna need a parentheses, I think. Okay, this doesn't look right. What's going on with you? It says r result plus minus. Hang on. Print the decimal value of each fraction on a new line with 6 places. So it just wants me to print the type of expression must be an array type, but is resolved to list integer. Okay, so how do I get I don't know how to do a list in Java. So list in Java. List interface in Java. List string, blah, blah, blah. Okay, list elements. Wait, print out list elements. List. String list. How did I do this again? List integer, a list integer named R, and then let's just find some functions for this. Add, list index of methods, list index of methods. Can I just have a list of all of the functions? I don't really need all this explanation. All right, let's look this up. Lists in Java. Java array list. This looks the same. Dude, well, I don't need all this stuff. I just need the functions. Is this? Oh, okay. Void add clear equals. Where's the access? Dude, what? Hang on. I'm like Geek for Geeks. Free Code Camp. Brother. List in Java functions. Add. Oh, how do you access? How do you access stuff? Where's the access? Is empty equals clear? What the hell? Oh my gosh. Okay. How to access elements in list in Java. Dude, I feel like this is so dumb. Get method? It's a get method? I have to do get? What the fuck? I'm doing that. String my list. It is get. That's so dumb. Okay. If r.get I equals 0, then we just do zeros plus, do that, and then do you not have that? Okay, you have that. And then we do continue from here. Now, and we just do the same thing 3 times. That's it. What is it doing? Why is it doing that? That's so weird. Let's do negatives next. Less than. I don't know what that was. Less than 0. Then we do negatives. Negative. And then we just go again. If you are greater than 0, then we do positives. Positive. Okay, there you go. Can I make like my own? Okay, there you go. So there's my 4. So this is fill get number of fill up or scan for positives, negatives, and zeros. Now we're gonna do calculate ratios Or no, print ratios. Print ratios. I don't know. It's not. It's actually not this. Okay, hang on. I don't know how to print in Java. Print in Java. Java output values. System.out print line hello world. There you go. Oh, I just realized you guys are not getting any desktop audio at all. There's music playing. There you go. That should bring some music. Whoops. All right. Print line. So print in Java. Formatted output. Print math. You do math in the print function of Java. How to print a method. I mean, I can just try it. So let's just do system.out.print line, and we'll just do positive divided by r.size. See if that works. Run code. Your output. Okay. Now, how do I precision? How to control precision in Java? How to control precision in Java? Print precision. Print precision in Java. How to control precision? Oh, hang on. I just realized. I have an error like way at the beginning. This thing. These guys. These need to be doubles or floats or something. And then this needs to change. Equals 0, 0 plus 1. Equals negative plus 1. Positive equals positive plus 1. It's not gonna give me. It gave me better, but I need the precision. So now let's figure this out. So using format in round, ouch. String format, string out format, blah, blah, blah. 20F. Number 20F. Dot 20F. 5. Okay, so this is kind of what I need to do right here. String format. So string format this. So let's come back here. And we'll do this. Take this. We'll do this string format. And then this is my B. We'll put 6 here. And then we'll take this. Positive. Put it here. Like that. That should work. Run code. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. That did it. Okay, so now we just need to copy this 3 times. Positive. Positive, negative, and then zeros. Zeros. Run the code. Okay. Submit. Sweet. All right. I passed. And we got time to work on some other stuff. Okay. Ouch. Woo! Okay, next. If I want to learn how to write Java, what order should I learn it? What order should I learn? Let's just do that. I didn't need to put a comma there. Whatever. Basic syntax and fundamentals. That's all fine. Object-oriented, blah, blah, blah. Methods, encapsulation, inheritance, polymorphism, core libraries, and data structures. Array lists. So that I worked on an array list just now. Haven't touched hash maps or hash sets, but I know what those are. String manipulation and string builder and string buffer. Okay, exceptions and handling, input and output, advanced abstract classes, inner classes, understanding static and non-static inner classes, lambda expressions, and functional interfaces. Optional for beginners for more modern approach to Java coding. Okay, multi-threading concurrency. This is stuff that I still need to learn for C++. Yeah, that'll be a little bit. All right. Practice with projects, build a small calculator, simple text-based game. Okay, next, let's work on another problem. Let's do a medium problem. Let's try to do a medium problem from LeetCode instead of HackerRank. We can maybe do one of the problems that I've done previously. Reverse an integer. This sounds hard. I don't remember what this is. Java. Okay, so it says assume the environment does not allow you to store 64-bit. Given a signed integer, return x where with its digits reversed. If reversing x causes the value to go outside of the range, input, output. Huh? Really? Can I just convert this to a string and then reverse the string? Okay. Okay, let's look at what we have available to us. Java strings. Character, data, string data. Java convert int to string. Integer.toString. Okay. Let's do string. String equals string result equals string dot to string, and we'll just put x in here, and then we'll do system dot out dot print line result, and then we might be able to just do result dot maybe reverse. Java convert integer string, string number, blah blah blah. I was taking a look at the value of the implementation in string class. The string will be called inside string.value of number by preference integer.toString. String.value of. I can do that. That might be better because I can keep it all inside the string library instead of like handling it within the integer. Okay, so let's do that. So we'll redo this. We'll still say string result is equal to, but we're gonna do in wait. Actually, I messed that up again. String value of. String dot value of, and then we'll put x here, and this should give me. Can I just run this? How do I run it again? Oh, here we go. Oh crap! Don't. What's wrong? This. Whoops. String. Class string. Location class solution. So I'm not allowed to use strings in here? Oh, crap. Okay, so I'm not allowed to use strings. So then we can do am I allowed to use arrays? What am I allowed to use? I'm not allowed to use strings. That's fine. So I can build the number, a character array. Okay, let's build a character array. Integer dot. I do have integer to character maybe. Integer to character. This might work. Let's see. System. Oh crap. Let's just do this inside of there. This away, this here, and then just run this and see if I get something. If I get something, then I know I can use integer. What did it say? Integer. Cannot find integer. Integer. Oh my gosh. Integer. Can't find symbol. Method to character. Convert int to car. Car in C is already a number. The character ASCII, no conversion required. How to convert integer to car in C. Loading to close as unclear, or maybe same as. Just cast it. Char to the int, where the int is ASCII set and reverse is also possible. Cast it? Okay. So let's do x.cast. Let's do, shoot, that's not what I want. Car x. Run it. Missing? What? Okay, let's look up casting. This is not C. This is... I'm looking at this in Java. Java. Sorry. Convert int to car. Use typecasting. Int is 97, car character, character name, num, system out print. See, this is what I did. This is what I did. I thought that's what I did. Maybe I'm wrong. System print car character X. What is this about? Missing. Where? What are you talking about? I am missing one. What? Where did you come from? Solution goes there. This goes there. What? What are you missing? Missing return statement. Return. Return. -1. There. Happy? Dummy. Standard out. Standard out? Why is it? What the heck? Okay, try that again. Okay. What the hell is that? Convert int to car. No. No, yeah, that's what I want. Int to car. Will print out the car with Unicode .1 starting of the head, which isn't printable. See this table. Int A is equal to 1. Car B is equal to car A. So we'll print out the car with Unicode code point 49, which corresponds to 1. If you want to convert a digital 09, you can add 48 to it and cast it, or something like character dot for digit. You can, if you want to convert a digit 0 to 9, you can cast it 48. You can add 48 to it and cast. Okay. God, I keep doing the same thing. Let's try that. And then we say x is equal to x plus 48. Try. Let's see what happens. Oh, damn. Okay. 2. Run. 2. Wow! You're so smart. Okay, let's duplicate this. Convert car to int in C++. No! Java. Can you just typecast it again? Car equals 3. Oh my goodness, okay. So I seem to have it. And then we're gonna say int I is equal to x They seriously just subtracted 0. Oh my gosh. Come on. But they put parentheses around this. Let's see if that does it. I should get 2 and 2, like right off the bat. Okay, good enough for me. So the goal, the idea is to get a series of characters. No, this isn't gonna work either. Okay, it's an hour. Yeah, I gotta head out. Alright, everybody, I'll work on this later. I'll see everybody later. Bye. Have a good day. Okie doke, stop this. See you later, guys.